There's a truck driving on European roads right now that almost nobody is talking about. It hauls heavy freight, it has diesel-level torque. Drivers operate it exactly like they've operated trucks for the last 50 years, and it runs on hydrogen. Volvo built it. They're testing it in real conditions on real routes right now. Commercial launch is targeted before 2030. And yet, the industry isn't racing to copy it. Fleet operators aren't lining up. The energy transition narrative has barely registered this as a milestone. So here's the question we're going to answer today. If the truck works, why isn't it taking over? The answer reveals something uncomfortable about how clean energy transitions actually happen, and it has almost nothing to do with the technology. The truck itself is genuinely impressive. Volvo's hydrogen combustion engine uses a system called HPDI, high pressure direct injection. A small amount of ignition fuel, specifically a renewable alternative called HVO, is injected at high pressure to trigger compression ignition. Then hydrogen follows. The result is combustion, real physical combustion, with hydrogen as the primary energy source. No fuel cell stack, no battery pack, no new driver interface. Just an engine that feels, sounds, and performs like diesel, except the fuel feeding it is hydrogen. Volvo's head of product management, Jan Hjelmgren, said it plainly. Customers will be able to operate these trucks just like diesel trucks. Same torque, same drivability, range that exceeds most customers' daily driving distance, and critically, the same refueling model fleet managers have built their entire logistics operations around for decades. Pull in, fill up, drive away. Here's the detail that almost every headline missed. Volvo has already deployed HPDI technology in over 10,000 gas-powered trucks worldwide. This isn't experimental engineering being stress-tested in the real world for the first time. This is a proven, mature technology platform being adapted for a different fuel. The foundation was already built. Volvo is extending it. That distinction matters enormously, and we'll come back to why. But first, you need to understand the real enemy of clean energy adoption. And it isn't cost. It isn't technology maturity. It isn't even politics, though. That's a convenient villain. The real enemy is switching cost. The full operational, behavioral, and financial burden a company takes on when it moves from a known system to an unknown one. And in trucking, switching costs are enormous. A fleet manager running 200 trucks across a national logistics network hasn't just bought vehicles. They've built an entire system around those vehicles. Route optimization calibrated to diesel range. Maintenance schedules tied to diesel powertrain life cycles. Driver training built on decades of diesel muscle memory. Fueling infrastructure at depots, at partner stops, at endpoints. Risk models that account for diesel's known failure modes. Everything is integrated, everything is optimized, and everything depends on diesel behaving the way diesel has always behaved. Ask that fleet manager to switch to battery electric, and you're not just asking them to buy a different truck. You're asking them to rebuild their system from the ground up around charging windows, range calculations, and infrastructure that may not exist at their delivery endpoints. That's not an upgrade, that's a transformation. And transformations, however necessary, generate friction. They generate delay. They generate the organizational equivalent of, let's wait and see. The clean energy industry has chronically underestimated this friction, and it has cost years of transition momentum as a result. Volvo's hydrogen combustion truck attacks this problem at its root. It doesn't ask fleet managers to transform. It asks them to upgrade. Same operation, different fuel. The behavioral barrier, whilst one of the most stubborn, underreported obstacles in the entire energy transition, is almost entirely removed. That's not a minor engineering convenience, that's a strategic breakthrough disguised as a product decision. Now here's where Volvo's strategy gets even more interesting, because they're not betting everything on hydrogen combustion. Volvo's full decarbonization roadmap runs 3 parallel paths. Battery electric trucks for urban and short-haul operations, where charging infrastructure is available and range is manageable. Fuel cell electric trucks for applications demanding zero tailpipe emissions with hydrogen's energy density advantage. And hydrogen combustion trucks for long-haul freight in regions where neither charging infrastructure nor fuel cell economics have yet reached maturity. 3 technologies, 3 markets, 3 infrastructure realities. One company hedging intelligently across all of them. This is sophisticated risk management, not indecision. The clean energy transition is not one problem with one answer. It's dozens of overlapping problems with different optimal solutions in different geographies, different applications, different regulatory environments. A global truck manufacturer with customers across 130 countries cannot afford to bet everything on a single technology winning everywhere. Volvo is essentially acknowledging what the energy transition narrative often refuses to. The future is plural. Batteries win in some contexts. Fuel cells win in others. Hydrogen combustion, imperfect, transitional, but immediately deployable, wins where neither of the others is ready yet. That's not a weakness in Volvo's strategy. That's the most honest strategic positioning in the industry. And now we reach the part nobody wants to talk about. Because here is the tension at the center of this entire story. Buried quietly in Volvo's own press release, skipped over by almost every outlet that covered this announcement. The truck is ready. The system is not. Volvo stated it directly. Large-scale deployment of hydrogen-powered trucks will require the rollout of hydrogen fuel infrastructure and a competitive price on hydrogen. Those two conditions, infrastructure and price, are not engineering problems, they're system problems. And system problems don't get solved by building a better truck. Right now, hydrogen fueling infrastructure is sparse, expensive, and operationally unreliable at the scale long-haul trucking requires. Green hydrogen, the only version of hydrogen that makes the well-to-wheel math work, is still significantly more expensive per unit of energy than diesel. The supply chain for delivering hydrogen at the volume, quality, and pressure required for HPDI combustion at truck stops across global logistics networks is largely theoretical, and the decarbonization promise itself is conditional. These trucks can achieve net zero CO2 well-to-wheel only if green hydrogen is used as the primary fuel and renewable HVO is used as the ignition source. Use gray hydrogen produced from natural gas? You've moved emissions upstream, not eliminated them. Use conventional diesel as the ignition fuel? The clean energy math gets complicated fast. This is what Renewable Energy calls conditional decarbonization. The technology is clean under the right conditions. Building those conditions is the actual challenge. And it's a challenge that no single manufacturer, however innovative, however committed, can solve alone. So why isn't everyone doing this? Not because the technology doesn't work. It does. Not because the performance isn't there. It is. Not because fleets can't operate it. They can almost immediately with minimal retraining. The real answer is that building a truck is a contained engineering problem. Building the system around the truck, the hydrogen production, the distribution network, the fueling infrastructure, the green energy supply chains, the regulatory frameworks, the financing mechanisms, is a civilization-scale coordination problem. And civilization-scale coordination problems don't get solved by innovation alone. They get solved by sustained investment, policy alignment, infrastructure commitment, and the kind of long-horizon thinking that quarterly earnings cycles make structurally difficult. The lesson here is not that Volvo's hydrogen truck is a failure. It's that the truck is ahead of its ecosystem, which is, historically, exactly how transformative technologies arrive. The electric grid existed before widespread electrification. Container shipping existed before global logistics networks were rebuilt around it. The internet existed before the infrastructure, the applications, and the user behavior caught up to its potential. The technology arrives early, the system follows. The transition happens when the gap closes. Volvo has built the truck. The question now is whether the world will build the system fast enough to meet it. Here's the frame we want you to hold. The clean energy transition is not a technology race. It never was. It's a systems integration challenge. And systems integration is slow, expensive, unglamorous, and resistant to the kind of narrative compression that makes for good headlines. The best technology doesn't automatically win. The technology that fits into existing systems, that reduces switching costs, that works with the infrastructure humans already have, that earns adoption through familiarity rather than demanding transformation. That's the technology that actually changes the world at scale. Volvo's hydrogen combustion truck is not the end game. It's the bridge. And right now, in 2026, bridges matter more than visions. The vision of a fully green hydrogen freight network is real and it's coming. But it doesn't arrive in a single leap. It arrives through thousands of operational decisions made by fleet managers, logistics directors, infrastructure investors, and policymakers, each of whom needs a next step that doesn't require betting everything on a future they can't guarantee. Volvo just gave them a next step. The truck works like diesel, it runs on hydrogen. It can be net zero when the system catches up. The technology gap is closing. The system gap is the race that actually matters now. And the companies, governments, and investors who understand that, who stop asking, is hydrogen ready? And start asking, how do we build a system that makes hydrogen inevitable? Those are the ones who will define what freight, logistics, and energy look like in 2035 and beyond. The truck is ready. Is the world?